I'm Dr. Henry Cryson, an applied plant pathologist at Scotland's Royal College. Integrated Pest Management, or IPM, is a holistic approach to managing harmful organisms that maximises profitability whilst minimising negative impacts on the environment. The impetus to adopt IPM has re-emerged in the last decade. However, a significant deficit exists in our ability to practically monitor and measure adoption of IPM on arable farms, so our aim was to establish a universal metric to do so. We conducted a farmer survey of over 200 farmers in Scotland, England, Northern Ireland and Ireland. Within the survey were questions related to adoption of specific IPM practices, questions relating to perception of IPM, and socio-economic questions related to the farm and the farmer. Through a lot of stakeholder engagement, we developed a metric to measure IPM adoption on a 0 to 100 scale. Our results showed that Scotland and England had higher average levels when compared to Northern Ireland or Ireland. We found that farm area was associated with a higher level of uptake, and we also found that familiarity with IPM increases uptake, as you can see from this figure. We're having a good working relationship with your advisor was also related to an increased IPM score. What we found is that information source is key. Those farmers attending farm walks, open days and discussion groups are much more likely to be familiar with IPM. Those scoring higher levels of IPM adoption were also more likely to value the advice of an independent agronomist. This figure shows the mean rating scores of importance of different information sources for the high scorers, the upper quartile, and also the low scorers, the lower quartile. We made no assessment of the quality of the advice from the different information sources. What's displayed here is simply the most valued information sources to those different adoption groups. What we find is that farmer engagement with knowledge transfer events has proven to be related to IPM familiarity and as a result, IPM adoption score. Actively seeking current IPM related advice can result in changes towards greater IPM adoption, but for these changes to be successful, they must be evidence based. This is why we conduct field trials up and down the country every year to look at how the effects of different non-chemical control measures can be combined in a way that reduces disease, reduces fungicide requirement and protects the yields. In winter barley, as well as looking at the effect of varietal resistance on disease and fungicide requirement and yield, we're also looking at the effect of varietal mixtures. So this is when 2 or 3 varieties are physically mixed in the field. These trials, who are kindly funded by the Mains of Lawson Trust, have been conducted for the last 3 years at our Aberdeen and our Lanarkshire sites. We find that under certain circumstances, different mixtures will over-yield compared to monocultures. In high disease years, we expect this effect to be greater, in that those mixtures will have lower levels of disease when compared to their component monocultures. We also have winter barley trials where we're looking at the effect of the nitrogen addition, whether the majority is provided at mid-tillering or stem extension, on canopy development, disease and yield. And last year we found that in these trials, also funded by the Mains of Lawson Trust, those plots receiving the majority of nitrogen at the start of stem extension had greater yields than those receiving the majority at mid-tillering. We also have sowing date trials where we're looking at the effect of variety and fungicide in plots sown fall. We're entering the 3rd year of those recess-funded trials at Boghole, and last year the early sown plots of susceptible plants yielded the worst and responded the greatest to fungicide inputs. This was largely due to significant amounts of tan spot, but also ramularia. These trials mirror a trial that we have in winter wheat as well, where we're looking at the effects of sowing date variety and fungicide, and we're also seeing that the greatest benefits in terms of disease reduction are seen when you grow resistant varieties and you sow them late in the season. We also have various other trials looking at the effect of different fungicides and alternatives to fungicides, which we conduct every year.
Over a number of years, SRUC has been investigating the use of diverse crop mixtures, sometimes called intercrops, aimed at providing a number of production, environmental and economic benefits to farming systems. One recent area of SRUC's work involves the investigation of a range of protein crops and growing systems that have the potential to provide reliable production across different regions of Scotland, primarily the southwest, northeast and central regions of the country. These protein crops provide potential options for livestock and human end uses, and as the intention is for them to be grown on farm or locally, they should help to reduce reliance on imported soya. SRUC's work in this area includes investigations at differing scales, using a range of small plot trials, larger field trials, and participatory trials on farmer fields, with this work linked to a range of funders. There is ongoing work investigating opportunities to improve the use of grain and forage legumes in a system context. Different management approaches are being compared, including the use of monocultures and mixtures or intercrops, often with a non-legume component such as a cereal, grass, herb or forb. Different harvesting options in order to reduce the risk of weather causing problems in the autumn have also been tried. So, for example, silage and grain harvest from the same base material have been compared. As well as yield, a range of crop quality aspects have been measured, including crop protein content and other nutritional parameters including fiber and trace element concentrations. A range of other public goods have been assessed in the experiments, largely based around long-term system productivity and efficiency under reduced agrochemical use, including things like soil, physical, chemical, and biological health tests, as well as in some instances pollinator density and diversity assessments. Examples of some of the range of crops tested in this suite of experiments include a range of clovers, white, red and crimson for example, other legumes like vetch, field peas, field beans and lupins and lentils, grown with or without a cereal, and with even tried growing soya. Other work has focused more on forage production, with, for example, the use of diverse herbal leys with mixtures of up to 18 species of grass, legumes and herbs aimed at improving production, feed quality and soil health with minimal inputs. Other public goods include a range of carryover effects linked to soil improvements. These include improved soil structure and residual nitrogen associated with the inclusion of the legumes. SRUC has also undertaken work in the past that provide evidence for similar benefits when following a cereal crop that is undersown with white clover. The overall impact is to make more efficient use of inputs over time. SRUC research has shown that beneficial effects of these types of crops can still be observed 3 years after the mixture or leguminous break crop has been grown, so gross margin should really take into account the impact over multiple seasons, but often isn't. Overall, the event at Stricken went very well, with around 25 attendees taking part in the discussions, focused on the perceived difficulties with growing oilseed rape organically, as well as marketing opportunities through Norvite, etc. It is hoped that as the project develops over the coming season, more useful information will be accrued to answer some of these points, and it is anticipated that further videos such as this will be produced to reflect this newly acquired information. Finally, thanks go to a number of influences indicated here. All the members of the operational group, and in particular, CATIF for financially supporting the project.